Thank you. Thank you very much. Yeah, I was here a couple of months ago, and my presentation was astronomical iconology on ancient coinage. Sounds kind of long-hairish, but it was actually a fun thing to do, and I've been doing that for many years now too. And actually, a few of those coins are going to appear in this particular presentation where it pertains to meteors. So let's start off by basic knowledge. Every day, we're bombarded with more than 100 tons of extraterrestrial material. More than 100 tons every day. And they happen to fall over the entire Earth's surface. They don't fall in any one specific place. It's random. There's even equations that talk about it, and they've done studies on it. They fall everywhere. Of course, it may not be easy to find them in certain areas, like in the forest. How are you going to find it? You can't see it. I would say that the oceans, the bottom of the oceans, are littered with meteorites. But it's easy to find them in deserts. And where? Antarctica, because the ice is melting, right? They've struck the ice, and as it melts, you can go out there and you can find it. So that means 18,000 to 84,000 meteorites bigger than that come to Earth every year. Every now and then we get big ones. Not in our lifetime have we had a huge one, but there have been some rather large ones. So once a year, one about the size of an automobile will hit the atmosphere. You saw the one that exploded over Russia, right? Happens a lot. There's bolides, lots of them. During star parties, we've seen many of them. Many different colors. Sometimes they split. They go into threes. They make noises. They make sonic booms. But they're hitting all the time. Okay, meteorite hunting. I'm a meteorite hunter. There's the definitions. And you see what they said? They're using metal detectors or magnets to discover the meteorites. That helps. There I am, Bureau of Land Management. Got my water jug, got my metal detector, and I'm looking for meteorites. I've got metal detector there, and I have a large earth magnet on the end of a walking stick. But generally, you want to eyeball them. Oh, I'm still out there. There's lots of rules now and laws regarding meteorites, unfortunately. And why are there lots of rules? Because people want to study the meteorites, plus they have great value now. There are many dealers with meteorites, and if it's a meteorite that's come from the moon, they can be hundreds of dollars per gram. And if they knew it's something that bounced off Mars, close to that too. But even other interesting ones, they all have value. Desirability forces the price up, so everybody wants to protect them. Right now, where's a good place to go and find meteorites? Death Valley for sure, right? Flat desert floor, guess what? You're not allowed to do that. Any national park, city park, state park, you cannot take the meteorites away. That is by law. I petitioned to be able to bring a metal detector into Death Valley. However, I got really close because my argument was meteorites are not indigenous to the park, right? They weren't there. They weren't formed there. Landed in it. Got really close until the very end. They said, nope, don't even bring your metal detector here. We will confiscate it. So, where can you find meteorites and keep them or study them? Private land, the way the law is written, if it's your land, you farm land, meteorite hits, it's yours. And then same thing, Indian sovereign land, the Navajo. If you have a guide and if you purchase time there to go look for meteorites, most people go look for Indian artifacts. I look for that too, but I look for meteorites out there. Then you have permission from them, then you can actually have them. And then the only other thing that you can do is go to BLM, Bureau of Land Management. That's open territory. And if you find something there, it's yours to keep. But even now, they've cut it down to only 10 pounds per year. So that doesn't actually sound like that much, but I'd be glad to have 10 pounds a year, trust me. Because usually the ones we find are very small and far and few between. Many people have brought me meteorites. Like, I found a meteorite in the desert. And I go, can I see it, please? Of all the rocks that people have brought me, how many are they meteorites or are they meteor-wrongs? Of all the ones people brought me, all of them, none of them have been meteorites. Because they're not what you think they are. Some people have bizarre ideas of what meteorites look like, feel like, and stuff, but we'll get into that. We'll talk about that a bit. So meteor, not a meteorite, meteor just goes through the air. You see the streak? That's a meteor, but it's not actually touching the Earth. But once it actually strikes the ground, then it's a meteorite. So what we call a fall is when a meteorite or meteorites were actually seen. They have a date, they have a time, they have a location. And a find is just when we're in the desert, we're wherever, Antarctica, looking for them, you stumble upon them, you don't know when it fell. So basically there's 3 kinds, and the third one is divided into 2. There's iron, which is 4.6% of meteorites, like the one that fell in Arizona. Those are easy to find because they will attract to a magnet and my metal detector will pick it up. Then there's iron stonies, which are a combination, and again the detector will pick it up and magnet will too. But then there are stonies, of which there are 2 types, achondrite and chondrite. But look how much percentage, 94%. So that means of 94% of all meteorites that strike the ground, my metal detector will not detect it, magnet will not detect it. You have to eyeball it. So what do? You're looking at rocks on the ground. Simple as this. Which one looks like it doesn't belong there? Which one doesn't look like everything else? I'm from Thunder Bay, Ontario, Canada. I'm a Canadian American. Came here in 1989. We're going to travel to Canada in this presentation 4 times. This is the first one. So you'll see here, I think the date, yeah, see December 14th, 2017. Stephen, he's a professor, Lakehead University, my alma mater, and a meteor struck near the highway in December. And he's out there with a team from Lakehead University to try and find it or try and study what the heck happened. And they claimed that they couldn't find anything. So I went the following May. This is my photograph. You notice how I matched it up. See that sign? See that roof? There's a sign on the roof. We found it. They can't hide this stuff from me. Okay, so I actually found the site, and look, the little wee crater is still there. Came with a metal detector, came with magnets, came with all kinds of stuff, dug around a bit. I searched all around, completely around, and I found nothing. Now, so some people are saying, oh, well, whoever was there first got the meteorite and they're gone and they're rich, right? Because 94% of meteorites that strike the ground are stony, right? Remember? This thing came in really hard and fast and it pulverized. And we don't think anyone has any fragment of it. But it's still very neat because it was witnessed, so it is a fall. And I found the actual location where it hit. Okay, but besides meteorites, chunks of the rock from extraterrestrial, they leave other clues behind. And some of them actually contain meteorites. Tektites, impact breccia, shatter cones, debris-ite, and impact lapilli, and we'll talk about those. Tektites. If you have a large enough impact, it'll come straight down, and then the surrounding rock there, sand, silica, will actually be turned to glass from the heat and from the impact, and it'll splash out. And depending on how big the impact is and how far it is, they have all these peculiar, different little shapes. So, a lot of you, have you been to the one in Arizona, big one? Okay, you know how big that is. Okay, remember that's 1 mile across, and when you're there, it's huge, right? Look at me standing there. That's a big hole, right? But these tektites, spherules, sometimes they call them, got ejected so hard that they were found in Tucson. And you know where that crater is, up by Flagstaff, right? That's a big distance, right? About 7,000 years ago. Hits them, and then they spin, make spherules. And they're mostly glass, so you could take a hammer, you can actually shatter them. Some actually contain chunks of meteorite, but generally they're like sandy glass. And then this one's Cambodia. It's really glassy, it's really quite a nice one. From China. And then from Australia. Multiple hits. They can find them in the outback, out in the desert out there, very easily. And Eurasia, many different ones. So they're all glass, but because of impact from meteor and nothing else. We're going to go back to Canada for a sec. During the Middle Ordovician period, 467 million years ago, we know that like comets and stuff, they can break up before they strike the surface. So there's bang in Oklahoma. What's that? Wisconsin? Is that Iowa? And look, one up here in Canada, near where I'm from, Thunder Bay, Ontario. Only that's the Slate Islands impact 467 million years ago. And you can see the sky shot. You can see the crater. And it has a central lift after, because it hit straight in and then lifted in the middle. So if you drive out to Jackfish, launch your boat, you could come across the Slate Islands and see this thing. Out at the Slate Islands, we find this, impact breccia. This was such a huge impact, striking the water, that all the material, including pieces of the meteorite, when it came back down, made like a cement. An odd thing. All this conglomerate thrown together, and there's no earthly reason for this stuff to exist like this except for an impact. And this is really heavy, probably has lots of meteorite in it. I hope I'll break it one day. We'll see, but that's such a nice chunk. So that's impact breccia. Now, a very interesting thing that happens from impact too is this guy. When they detonated the atomic bomb in Nevada, they found that when it detonated, the adjacent rock experienced shatter cone. And that's where the stone actually, from the impact and from the heat, stretched the rock. Didn't break it, it stretched it. And only severe impact or explosion can do that, and it's called shatter cone. You see these? They're sort of triangles. If you come up and take a look later, that's this piece of shatter cone from Slate Islands. So from the nuclear bomb, they made shatter cones 1/4 inch. These ones on the Slate Islands are 16 feet tall. So that was one really big explosion. Okay, this is one of the most known meteor, comet, asteroid impacts on Earth, the Chicxulub. This was a dinosaur killer, right? Yucatan Peninsula, and they're actually doing studies on it now. They're actually digging down there. I would love to be on that team down there digging, seeing what they're going to find. So it was 66 million years ago, and remember, it killed the dinosaurs. But here's the surprise. It's only the 8th largest known impact on the Earth. All the other ones came earlier, of course. This is the biggest. Now remember the Arizona crater, 1 mile across, and you know how big that hole is, right? It's 190 miles wide. Now, if there were dinosaurs at that time, they would have been gone too. And everything else, right? This precedes the Chicxulub. But this is a monster. This is the second largest one, Canada. We're back in Canada right now, third time. This is an article from Astronomy magazine several years ago. And remember that's an article in Astronomy magazine. So it hit here, Sudbury Basin, and had a splash zone. It was so huge that the debris fell as far as where I'm from, Thunder Bay, and on the Gunflint Trail in Minnesota. And we think that generally it came in at an angle from here to here, because they're not really finding much out here. So they think it came in at an angle and pushed everything out there. But look how far away they're finding that. From here to here is 500 miles. And the crater itself, it's 160 miles. So here I am in Thunder Bay, and we found 4 sites where you could find this debris-ite from this meteor splash. And it's this particular layer in this rock here where I'm pointing to. And in it, we find this debris-ite and impact lapilli. That's a funny word. That's this. When you come up and take a look. When this material impacted and was thrown that far, it gathered gas bubbles. And it's the only way you can get some volcanic lapilli, but from impact lapilli, the only way you can get it is from a huge impact like this. Now that article from Astronomy magazine, he was one of the contributors, Gregory Brumpton, and he was showing me several places where this debris-ite was found. This is Hillcrest Park, this is Ballpark Central, and these were at the Terry Fox where I was standing in the previous shot, and Gunflint Trail in Minnesota. Here's an interesting thing about the Sudbury impact. For years, a huge mine at Sudbury was mining nickel. We as Canadians knew that our nickels attracted to a magnet. Whereas here in the US, they're saying, no, nickels don't attract to a magnet. But if they're pure nickel, especially if it comes from a meteorite, it's magnetic. We knew that as kids because I'd hang out by the stores when I was a kid in the 50s with a fishing rod with a magnet on the end, and people drop coins like right in the sewer and stuff. You drop down there and click, 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 click. You're picking up nickels, right? Heck with the pennies. We're going to get the nickels, right? So, of these nickels, where it says, see, 99% nickel, 99%, 99, 99, and 95. These dates, those 5 ranges. I have 10 nickels here, 2 each from each of those 5. This is an earth magnet. Ready? Listen to this. They're all stuck to the magnet. Now, once that kind of got out, there was a run on our Canadian nickels. People go, oh, those are meteorites, meteorites. Of course, it's been smelted, and there's real nickel in there too, because this thing, when it hit the Earth's crust, it went right down to the magma, so real nickel came up and it combined. But as time went along, they noticed this nickel mining is not behaving like nickel does. Well, of course, this huge meteorite came in that was mostly nickel. We have some very large meteorites. This one's in Chad. This is from Africa, and they just actually left it where they found it. It's just too huge. And they built this little auditorium thing around it where you could go in there and see it. And this is El Chaco, that's in Argentina. And this is one of the largest found in the United States. It's the Willamette meteorite. And look at the kids are even in the burn holes of it, right?
Where's that at?
It's on the East Coast. Oh, pardon me, Colorado. Now, micrometeorites, tiny. So we have Chicxulub size, then we have big ones, we have like the ones on the table, and then right down to micrometeorites. And how do you find them? After the rain, that's me gathering all the dust off my roof and in my gutters. And then after you sieve it and then draw it away with a magnet, put it under electronic microscope, you see all this cool stuff. Not all of it's meteorites, no way, but every now and then. Very glassy, that's a micrometeorite. And I brought a little thing of several of them. And actually they're really studying them now. These are two that I've got. Those are 220 power. They're tiny, almost the size of a grain of dust. This is John Larson in Norway. He studies these. He really aggressively goes out to get the dust off roofs. But look at the fabulous meteorites he's found. Micrometeorites of all kinds of materials, including olivine, gold. All manner of materials, irons. And then here's the latest set. Look at them. Olivine glass with a little iron deposit in it, nickel. And these are tiny, tiny. His microscope way better than mine. And look at this glass. They're beautiful. And they hit all the time. Especially if it's raining, they'll zoom in, be encompassed with raindrop, and then fall right on your roof without shattering. And then you can actually get your hands on them. I did the ancient coins, multi-things last time, but we'll just do the meteorites. Elagabalus, he was a Roman emperor, and if you think Trump's crazy, this guy had him beat by a long shot. This guy was wacko. They had this meteor, kept it in a shrine, and then pulled in the cart of Astarte, there it is there, by sometimes 4 to 10 horses on display, dragging this meteor, because it fell during his reign. Of course, he's saying, well, this is God saying, I'm the greatest ruler of all time, right? Right? God sent his message, here it is. And here, the Roman eagle on top of a meteorite. And this is a particular beautiful one. It's Greek. And you see this omphalos that he's sitting on? It has a net with adornments. What it is it's a stone, and it's the oracle at Delphi, because they have since found it. Location. Because everyone thinks the oracle is a person. No, the oracle is a sacred stone that fell from the sky. So that's what the omphalos is, Delphi, and it's the oracle. Speaking of sacred stones, if you go to Mecca, and the Islamic, they go counterclockwise around this building, and on the eastern side is this silver enshrouded stone, and inside it's actually a meteorite. And they believe it was God-given because it fell from the sky, and it's been there for 2 centuries. And also in Egypt, this is King Tut's knife. When they finally opened him up, he had it on his thigh. And it turns out that's meteoric iron and nickel. And has the same composition as this meteor found here, 150 miles west of Alexandria. So we know actually even where it came from and where it was fashioned from. Because even in his time, iron was worth more than gold, because they were only in bronze and copper yet, and hadn't really gotten up to fashioning iron effectively yet. They're on stamps. Any stamp collectors? Look at all these. The one I just showed you in Southwest Africa, in Chad, that's how it looked when they found it. And now they've got like the amphitheater around it because it was so big they just left it where it was. These were all witnessed in Russia when it was USSR, and in France, Angola, and France again. Anyone want to try and take a shot at pronouncing that? Fortunately, before I retired my company, our manufacturer was in Sweden, so I got to go 11 times. And then, being meteorite hunter, I had to go to this one area. It's pronounced Muonio-Nalusta. And the reason is this meteorite was found on the banks of the Muonio River. And then they've chopped it up. It's a beautiful octahedrite meteor, very expensive. But you know when you buy coins or bars and stuff like that, it says 0.999 silver, 0.999 gold. Look at this. 0.999 meteorite. It's the only one that's made completely from meteorite. They cut off just enough to do it. And then they put this image on it and buffed it so you can actually see the octahedrite pattern on there. This is a beautiful, beautiful coin. When they first came out, they were about $750, something like that. And there's not that many around, and they've all since disappeared. People have bought them. They're gone into private collections. And the meteorite itself travels around. It's been in Stockholm and stuff like that. Last I heard it was in Prague, but it's probably back in Sweden by now. But you're in Sweden. You're looking at this, you go, okay, that's $750. I don't know. Then there's just silver coins that they put a little piece in. You see that? So you can own it. But being a meteorite hunter, I went for the actual meteorite itself, octahedrite, because it's beautiful. I didn't really want it made into a coin or anything like that. I went for the real thing. Campo del Cielo. This is the large one, El Chaco, that's in Argentina, and there's other chunks there. There's lots from Argentina. This coin they made looks like a crater. It's very artistic, and they put a little chunk of the meteorite in it. But again, I prefer to get the meteorite itself. This is from there. This is the Sikhotalin. It's in Soviet Union. It was actually seen. So that puts a higher value on it. If someone saw it and you could put a date to it, maybe went and got it, the value of the meteorite actually goes up. And they made a coin and put this little chunk in there. But again, I prefer to get the meteorite itself, chunk. This is Nantan, China. Rather large, but again, they cut away enough of it to make these coins. These are silver with a little piece of the Nantan, and it's a rocky meteorite. This guy. I like the coins. I just like the meteorite itself better. The Cook Islands have done a lot of them. This one set is particularly nice. But look at this, they make it look like a crater. Exactly how it was found. You can get them graded, buy them in sets. And Niue Island also put these up. This one's real nice crater. Actually, that's a U.S. impact. So I thought I might, if ever I buy it, I'll probably get this one. This is the upheaval dome, Colorado. Palau put a nice one out as well too, with a Nantan in it. And Northwest Africa, they find lots of meteorites on the sand in the Sahara, lots of them. And then some are from Mars, they prove. Some are lunar. These have very high value. They're very expensive, hard to get. Another Martian meteorite. And then the Fiji Islands, what I liked about the ones they did was, do you see they put loose pieces under glass on the coin? You know, they kind of shuffle around. I think it looks, to me it looks better than just embedded. And then we'll end off with this one. Going back to Canada, fourth time. But actually it's a disappointment to me. To celebrate astronomy in Canada, its anniversary, they made this beautiful coin, a $20 silver piece. You know, they got the great galaxy in Andromeda there. They got the great eclipse of August a few years ago, moon, and pillars of creation, very good. But the meteorite they put in there, did they put it from Sudbury? No. They put the one from Argentina, which I found very disappointing. Had it been a Canadian found meteorite, I'd have bought it in a flash. So that's a bit disappointing. I think it's a beautiful thing, but doesn't meet my particular interest. And with that, I say thank you. Are there any questions?
I got a question. The one that she showed from China, but then the coin said Republic of Palau. How does that come about?
He's asking how the one meteorite came from China, but Palau and all these other places made the coinage. It's simple as this. Those islands that minted those coins paid money to those countries to buy a chunk of that meteorite, and then they put it into their coins, but still attributed it to that meteorite fall, including Canada doing the same thing. A question back there.
The ones from the moon and particularly Mars, are those ejections from volcanic activity?
No, he's asking about the meteorites that we find on Earth that they can attribute to the moon or to Mars. Actually, it's probably a large meteor strike that hit one or the other and then blew that stuff right off of the planet or the moon itself, because they don't have as much gravity as here. And so they just drift around in space until, boom, they fall on the Earth.
So therefore, those meteorites could be debris from the meteor that hit Mars and not necessarily the rocks or whatever that were native to Mars.
Yeah, I know what you're saying, but he's asking if the material is actually the original meteorite that struck Mars or struck the moon, when actually no. They can tell from the material, the ejecta, just the same way as tektites are. They know that that material that they have in their hands is a piece from Mars that got thrown off the planet and landed here. And if you find a piece of meteorite that did that, you would probably not even know that it did that, right? All we know is once they do the spectra and everything and testing on those stones that they find, where it actually came from.
Hi. When I first went on a trip to Griffith Park, was with the Astronomy Club, and we happened to be there on a Friday, and that meteorite had come into Russia on that day or the before. So what happened to that?
The meteor that went over Russia, it actually mostly burned up in the atmosphere, yet many pieces of it fell to Earth, and they're collecting them now, and I see them for sale all over the place. But then again, a lot of it's probably phony, which you don't know how to trust it. Not long ago, one came over San Francisco and then sort of obliterated in the atmosphere and then fell right between Sacramento and Lake Tahoe. So people went out looking for them. And here's the funny thing. Normally you go to the places I described to find meteorites, but when it happens like that, you go to places completely the opposite. The people that actually found them, where did they go? Big parking lots and swimming pools, right? And that's where they would find pieces, because that's where you're going to see them. If they fall way out in the desert, and it's going to be hard to find, or if it falls in forest, like around Lake Tahoe, you're not going to find them. So go to the open spots, whatever fell recently, and they find it.
How close?
Sure. Any other questions? And when we're at the table, you're looking at stuff, you can ask all you want.
How often do you go hunting for meteorites?
I like to go, well, whenever I get the opportunity, when I'm not doing other stuff, several times a year, but even when I'm looking along the beach, and you're finding rings and quarters, whatever, I'm still looking for meteorites that could have hit the sand. Anything. I go desert a lot, and I want to go to Antarctica. I'm going to still try and work that out. And whenever I get the chance.
What altitude do they begin to burn so that you can see them?
See?
What speed are they traveling?
Oh, what time do they, how fast do they come in? Generally, if they're going to really do like that burning thing, they're coming in about 30,000 miles an hour. However, the ones that come in and, hit and we can find them, if the Earth, picture the Earth is going around the sun like this, right? And you've got a meteorite. If it's coming at you, it's going to come in at 30,000. However, if the Earth spins around and it's coming like this, do you see? As we're going this way, it can come in slowly. So they can come in at all different speeds. But generally, once they hit the atmosphere and gravity takes over, they're really, really fast.
And about what altitude then are they starting to burn?
They can burn at almost any depth into the atmosphere.
At what point is there enough atmosphere to ignite?
Yeah, it has to get down pretty, for it to burn up in the atmosphere, it has to get down pretty low, really pretty low. And I've even heard them, like we've gone to see the Leonids and the Orionid meteor showers and stuff, and sometimes they come right through the clouds and you can actually hear them sizzle, zip, 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 like that. And if they're large enough, they'll actually break the sound barrier. But they usually burn up before they hit the ground. Sad. We had one come straight at us once at a star party. We saw this light and we're looking at it, and then it just sort of disappeared. And I said, Fred, I think that was coming at us. And sure enough, another report came from Solana Beach that had the trajectory coming right at us. So it was, we saw a little red light, and then boom, out. So instead of seeing a long streak, we saw it nose on. It was odd. Good thing it didn't hit me in the head. Only one person in, of anyone we know has been struck with a meteorite. It was a lady, I think it was in Australia, was it? She was laying on the couch, and it went through her roof, through the upper story, and hit her in the hip. She's okay, she's just black and blue, but they had a meteorite. And another guy who was driving a Ford Fairlane a number of years ago, and it hit right in the hood of his car. So that's pretty close. Any other questions? Other than that, feel free, come on up, and we'll take a look.
What kind of reference would you recommend for people to learn more about how to go look for them?
To look for meteorites? Yeah, the first thing to do if you want a reference to looking for meteorites is there's laws. Because you don't want to go to all the trouble and find it and have someone take it away from you, right? That's kind of sad. There's many laws. Of course, I have them all downloaded, PDF. But just look for meteorite law. And there's, rock hounding law, too, that allows you to take some stuff. Because if you can't prove it's a meteorite, you declare it rock, right? And then I think you can carry maybe 40 pounds. So, we want to kind of bend the rules sometimes if we can here, right? But yeah, the best place to find them is where you can eyeball it, right? Flat, ancient, dry lake beds around here, that's the best. Any flat stretch that you have permission to go there. Simple as that. I like to befriend farmers. Hey, do you have a rock pile? Because the tractors, they're pulling rocks up, right? So that they can farm their fields. Want to look in that rock pile. Haven't found anything yet, but one of these days maybe there's going to be a really good rock in there. One more?
Those weight limits, is that per expedition? Because who's counting?
Yeah, no one's counting. Like if I went tomorrow and I found 10 pounds rock, right? If I went 3 weeks later, who in the heck knows? But if you want to catalog it and prove it what it is, you have to say where it was you found it, by coordinate, and when you found it. So you want to be truthful, right? If you're going to get these things, cataloged and then verified as a meteorite. Because it's one thing for me to say, yeah, that's a meteorite, but it's another thing if Dr. Alan Rubin says that's a meteorite,
As long as they're all from different places, it could be the same meteorite, because if it's spread across a large area, you could find some in one place, some in another place. You put down the coordinates, but you could go over to 10 pounds because you were at different locations.
Yeah, but they say 10 pounds per year, BLM. Okay, so we can probably stretch it a bit, but I don't care to. Like if truly I found 10 pounds tomorrow at the BLM, I would probably not look for the rest of the year until the year went over, just for the sake of it, and then start over again. Because I wouldn't want to find it and then not be truthful about it. Go ahead.
I have a comment. I have a picture of a rock. A rock has a picture on it, and it has the planets on it. I think it looks like it's got Jupiter. Yeah, it's a meteorite. Excuse me. I do have a speech problem and still apology. But I do I have a lot that has a picture of one of the planets. I don't know which one. It's a really, really wonderful piece of memorabilia to me because I didn't take too much for it. But
Okay.
And I'm thinking about probably letting you see it maybe.
Okay, now is it just a rock that someone painted, or do they think it's a space rock?
It is a real rock because I bought it at the observatory, the park observatory when I was living in Los Angeles.
Okay.
And had one thing, and then I had geoids that didn't include geoids. The geoids that I have blue rather than amethyst. I have a gold out geoid, and I have other things like that in my possession. I paid a little bit for them, but that's just, but in any case, it's talking about that. So
Okay.
this is what I have.
Okay.
Alan,
Super.
where do most meteorites come from?
Say again?
Where do most meteorites come from?
Most meteorites come from early formation of the solar system itself. There used to be way lots more, but they've all hit Jupiter, they've hit the moon, they've hit Mercury, they've hit us. So it gets less and less each year, but they're still out there. And then there's what we call the asteroid belt. They're not exactly sure what caused that. Could have been a planet that got obliterated. And so there's still lots of remnants from that floating out there. And if they get perturbed, like gravitationally get pushed off their course, they could wind up here. But fortunately, we have things like the moon in the way and big old Jupiter that is the big attractor. It gobbles a lot of stuff up so it doesn't hit us. Any other questions? We good? Feel free to come on up, take a look. You can ask questions.
We had a really good time, and this is very good.
I brought my flashlight because it's always dark. And see, yeah, the thing with meteorites is they're really, really dense. They're very heavy. They don't have any gas pockets in them. They don't have that. And feel how heavy that is, right? Because there's a lot of meteorite in there. This is my most expensive one. This is the one from Sweden. It's an octahedrite, isn't it beautiful? Yeah, it's kind of frail, so I don't want anyone touching that. Yeah. And this is the one Allan, that's from Soviet Union. This is Argentina, and this is from Nantan in China. And in Northwest Africa, I have about 20 of those. And then, okay, remember the lapilli I told you about with the gas bubbles? See all the little circles in there? Yeah, this is the debris-ite that after that huge impact that landed in Thunder Bay, Ontario, like 700 miles away. And then this loose debris-ite, all this crap, that got thrown from it, and contains a lot of nickel. And there's our Canadian nickels on the Earth magnet, right? Your nickels don't stick to a magnet. Ours do. And this is the breccia from the impact Slate Islands. You want to feel how heavy that is? Right? Yeah, because it's probably filled with meteorite. I've already picked out 2. But one day I'm going to cut it in half and then polish it and see what's in there.
That'd be interesting.
It looks like a cow pie, right? But there's no reason for these to exist except from a meteorite impact, because it struck the ground right through the Lake Superior, right, which was much larger then. And then when all this mud and junk comes back down, like this conglomerate, these things have no business being like this, all mixed up, except for the meteor did it. And then remember the shatter cones I told you, when the rock stretches, like from the atomic bomb? Do you see how the rock is stretched? Do you see the lines there? See? That's shatter cone. And that's from an impact. But the ones on Slate Islands, they're 16 feet tall. The ones on the nuclear bomb were 1/4 inch. And these were 16 feet tall. That was a big boom that hit the ground back then, right? And then these are all the glass ones, you know, like when a meteor hits, and they go off and they spin, right? You know, so they're roundish mostly. Some have points. This one's Arizona. This was found in Tucson. Tucson, from that impact. And this is in Texas, from a meteor that struck Mexico.
But the impact was in Flagstaff, you said?
Yes.
Yeah.
And they're found all the way in Tucson, right?
Oh my gosh.
And here are ancient coins. You see, okay, there's the cart of Astarte with the stone in it. And do you see the eagle sitting on the stone? Both of these, right? And there's the omphalos. And do you see the stone in the temple of Kaisos in Greece? And then the eagle on 2 of them. This is 2nd century, and this one is 300 BC. And these are 3rd and 4th century AD.
And this one is
This little guy?
Yeah.
This one was found in Belarus. It's kind of a rare meteorite. It has a tiny bit of gold in it.
So where was that found?
In Belarus. And then the micrometeorites that I found in my roof. There's several in here.
Look at that. Oh my heavens.
Going home and look at my stamp collection.
Slate Islands from Thunder Bay.
Okay, about 130 miles away. You go from Thunder Bay to Terrace Bay and then drive out to Jackfish and then launch a boat from there's lots of launch and then just straight across. And it's only like 1.5 miles across to the Slate Islands.
And Thunder Bay is how far from Toronto?
1,000.
It's 1,000?
Yeah, 986 miles.
Lake Superior. Oh,
You got a whole bunch of lakes to get through. Yeah. Ontario is a big state. Heck, it's even bigger than Texas. Yeah.
all those states.
This is so fascinating.
This one, right?
Yes, this
right?
one really is.
It looks like a big cow flop, but
Yeah, it's not a pretty one.
no,
it's
but
a
the
fascinating-
only reason it's like that is because the meteor did it. And do you see like chunks of all things that have no business being, but do you see this smooth one? That's a piece of meteorite right there. That one, yeah. And then let me see if I get my Earth magnet out of here. Yeah. Watch this one. Now do you see? See, this one is pure iron, right? So see, but now watch. The one from Nanton is a stony iron, so it's mostly stone, but just a little bit of iron. So it just barely, you know, goes. But see, but this one's not. This is a stony, right? And then this one's pure nickel iron, right? If I put this on this one, watch these guys. If you can see, I'll do it over. See? See him dragging him? Right?
So iron also is attracted by the
Iron and nickel to a magnet, yeah.
Would you sometimes confuse the two, whether it's iron or meteorites?
Frankly, when I get them, I don't care which one it is. All I go is, I got a meteorite, folks. And then I have a walking stick with a very large Earth magnet. And even when we just do hikes anywhere, I'm just touching the ground, going in. And then when I come home, I pull them off and let's see what we got. And then you just scrape it off and some of it goes in there. Because you do find them.
This shape or some piece.
Because they've spun, you know. It all depends on how big the meteor was that struck it and how far it's going to eject this stuff and what angle, right? They all have different shapes. Some of them look like little dog ears, and because then they spin, you know, and some of them are long spherules. Some of them look like spear tips and stuff. They mostly look like this one and mostly look like this one. Mostly.
I'm going to dig up my yard.
There you go, right? Because they say that meteorites fall everywhere on the planet equally, right? So they could be anywhere. You know, or you're walking on them and you don't even know it, right?
Sometimes the beach they have all these stones.
Nope. 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 They fall equally everywhere on the planet. Magnetic field has no impact, no nothing. They fall anywhere. Anywhere and everywhere.
When you come to the beach sometimes, they're all just littered with stones.
Yeah.
Littered with stones.
You want to take a look at those stones, you know?
What would you look for? And like,
Okay, if it's an old one of these and it's been out for a while, they'll actually rust. So they'll look reddish, right? So you can look for that too, of course, right? But you want to look for which stone doesn't belong here. These all look the same, but this one doesn't. Why, right? And pick them up. Pick them up, you know, and then try and determine what is. Do you feel that one? That flat one like this?
Is that looks kind of like this? That one over there, that one in the
With this guy here?
Yeah.
Yeah.
Real shiny. Like
Yeah, I know, but
volcanic.
that's
Oh my God.
that's solid iron and nickel. And you feel that weight, right? When people bring me stones and they think it's a meteorite, as soon as they drop it in my hand, I go, no. Because I can tell it's got no weight to it because it's full of air bubbles and like from volcanoes and from just the way, glaciation and stuff. But these things are very dense, very, very dense. Right? Yeah, but feel this guy even, and it's not even all meteor, right? Yeah. Right. Heavy.
What makes it so? Is that just a regular stone? Then you say there's
Most of it, yeah, but well, I think there's a lot in there.
some in
Yeah.
there then, which would
Yeah.
make it heavier.
And I think that they were stony, see, because I'm not picking, I'm getting a really, really, really slight pull on my magnet, like right here, a little bit in here, and they're just a tiny bit. But it's a stony like this guy.
I get a catalog for jewelry, and they have watches with the meteorite face on them. Is that real?
That's a hoot.
Isn't it? Our nickels, right?
That is
The U.S. nickels don't. And the thing is, they are so strongly magnetic that even after a while, they will magnetize for a while. Even they've done that, you know, because they pick it up. They're such pure nickel, you know, from the magma and from the meteor itself too. Right?
So when you go out to BLM land, you go out there camping? Or?
Yeah, we've done that because we have star parties, you know, and then before and after we're looking for stones and stuff like
You're
that.
out there, yeah.
The one time I thought I had it made in the shade. I do another crazy thing. Okay, you know what Google Earth is, right? You can look down. Instead of looking map, you can see the ground, right? You can see your own house, right? Well, I knew I was going out to the desert, and what I did was I found that area, Google Earth, and so I was just on the computer screen just scanning it, just looking to see if I see anything, right? And I'm looking, all of a sudden I stop and I go, look at that. And there was a big ring like this, and I go, oh, looked like a little crater or like a little boom, you know, and I go, this is so cool, right? So I marked it and I had it, you know, it was on my GPS and stuff like that. Let's go, let's go, let's go. Now, some people would say it was great what I found, but I was so disappointed. It was a Native American stone ring. But I mean, it was really good. There were, you know, morteros and really neat relics and stuff there. But I was like, dang it. You know, everybody else would go, oh, this is so cool, right? Let's look for arrowheads, right? But no, I was so disappointed because I wanted to find a great big one of those that she has in her hands, right in the middle of that. Boom, right?
Wow.
That is interesting.
But it does. But I still do that. I still do that. Yeah, use Google. When I know I'm going to a certain area, like Bakersfield, way out there, I'm going to look and look very, very carefully, just to see if I get a head start and say, well, this looks interesting. I want to look at that. I want to look at that. Then you get, you know, and then when you put the center on Google Earth, it gives you the coordinates: 33 degrees, this, 104, right? And then I put it into my GPS and then walk out there until it matches. Oh, there it is, right?
fun is
It's
that?
amazing.
You know, keeps me off the streets.
I said I got a catalog that shows watches with meteorite faces on them. Would that
Yeah.
be legitimate? It seems like.
Yeah, it's an art thing like those, yeah.
Yeah. And you don't know, they didn't say what kind it was or anything. So
They probably do. They probably do.
Oh, you said that was an earth magnet? You use that name?
Earth magnet, they're really, really strong.
Okay. So I've seen them, but
You see the shatter cone?
Oh yeah, that is so cool. That is so cool.
Stretched?
Yes. From heat and impact, that happens so quickly in the flash of an eye that it stretched the rock. So it's kind of brittle. Like if I drop that, it'll shatter.
Ooh, you didn't think it was shale or something?
No, I forget what
Is
kind
it
of
very
rock this
heavy
is.
it is?
No, it's actually like that's why it stretched.
Ooh.
If it was a strong rock, it would have obliterated it.
Yeah.
But that's from the Slate Island's impact, and so is this. Both of these. From the Middle Ordovician period.
You have to really know what you're looking at.
Yeah, you have to really learn how to eyeball the stuff and know what you're looking for. But see, it's not just meteorites, but it's all the other stuff, the other evidence you find, right, that you didn't even know about, right? Yeah.
What is this one?
Okay, this is the Muonio-Nalusta meteor found in Sweden that they made the coins from and stuff. But I got an actual piece of it. I didn't want the coin. I'd rather have this. See the octahedrite pattern in it? That's only meteors that do that. So if I cut this one, and polish it up, it will look close to that. See,
All meteors would look like that? in
Generally, yeah,
size?
and the stony ones have chondrites and achondrites, little round circles in them, which is unmistakable, not like any other rock on the planet. Because it's so dense. Because out there's no air when they're forming, right? No gas bubbles, no nothing like that. It's going to be dense as dense can be, and that's why they're so heavy. But this is one of the prettiest meteorites on the planet.
Pretty. And are there still samples available in Sweden?
No. And the coins are all gone into private ownership and stuff. I don't see any of them available anywhere.
Interesting.
Because meteorites are very
meteorites.
sought after now. Very, very sought
All
after.
meteorites will have that design. So you
Or close to that, yes.
Or
Yes.
this stretch mark. But this one doesn't.
No, because this is not a meteorite itself. This is what the meteorite did to the ground.
Okay.
Impact breccia.
Oh, yeah.
Now, do a lot of meteorites have this, looks like they've been heated and grounded?
Well, this is a tektite. This is a tektite. When it hit, it heated and blew out all the silica, the sand around it, and splashed it all out. And as they went, they spun, and they were hot, right? And they turned into glass. This is actually a form of glass. So this is not the meteorite itself. This is what the meteorite did to the ground. So that you can prove that what those are. That's Northwest Africa.
Even better.
Yeah, but it has that.
It's a stony one only. It has no iron in it. No iron, no nickel. But 94% of all meteorites are like that one. So you have to eyeball it. You can't metal detect it because it won't set my metal detector off, and it won't attract to a magnet.
Do you have a very high caliber metal detector, or do you have one?
I have a good one. See, the thing is,
what's Costco I got for my kids.
Yeah, I know there are. Even the cheap ones are good for meteorite hunter because they say you can find iron really quickly, and they give different tones. Like most people that get one of those, they want to find gold, right? And I'm not going to find gold. Yeah, so I give that. And so, because if I'm metal detecting and if it goes really high, beep, that's gold, and then beep, that's so. But if it's that's when I get surprised because it could be this guy right there in it. That's what I'm looking for. But then when you're digging in the desert, what do you usually find? A bolt from a motorbike, right? Or you dig again a license plate off an RV. Or you're digging. I found a hinge out there once. I go, how did a hinge get out here? And what do I find mostly in the desert? Bullets. Expend bullets or bullet shells. Tons of them, right? Just, meteorite, bullet. You know.
Which kind of meteorites do you tend to find the most of? You find?
Of the few that I've found, they are like this guy.
Okay.
Yeah, metal, because the metal detector will set it off, right? Mm-hmm. And like Canyon Diablo, were the great one in Arizona, right? All those areas, because it has a lot of ejecta there, where people are kind of looking. Technically, they're not supposed to, but everybody does it, you know, so.
When you go, are there other people on a Sunday doing the same thing that you
Sometimes. I like rock hounds, you know.
Yeah, and do they
When I was on Route
chat with each other,
66.
or everyone's very quiet?
Oh, they're just minding their own business. Yeah, I ran into some rock hounds too when I did Route 66 with my wife. We did from Chicago all the way to Santa Monica Pier, 19 days. And, you know, we stop in the national parks and we stop in all these kind of things. And then when we're up in Sitgreaves Pass, there was a guy out there on a motorcycle just banging on rocks. He and I had the greatest long talk. That's my kind of guy out there, you know, all the stuff he found, you know.
You said you went to Death Valley. I hope it wasn't in the summertime.
No, March, I think. Yeah, and it's the prime place in Bonneville Salt Flats to find meteorites, but they are not yours if you find it.
Do you go to Quartzsite?
Quartzsite, we've been out there. Oh, yeah, too. And then all those. Yeah, and then to those other places around Death Valley, Leadfield and Rhyolite and all those places. Those are good places to find these guys. And then BLM land in California, there's so much of it. It's just that most of it is really slopey. But that's okay because I know, okay, if a meteorite came, it would hit, and I bet you it's going to roll down, right? It's going to find its way down because it's heavy, right? So you don't have to go right to the top of these hills, right? You kind of just scoot along the little valleys, you know, with the metal detector, right? And try and find them that way. You have to think like a meteorite, right?
Do you mark your car with a GPS so you know its coordinates?
Mine, oh yeah. We know where they are. Oh yeah.
He doesn't get lost then.
No.
I get lost all the time.
Yeah. And then we do star parties out in the desert, you know, with the telescopes and stuff. Kill a couple birds with one stone. You know, when it gets dark, look at the stars, look at planets and stuff. Next morning, start looking for stuff, right?
Well, do you go out there and camp? Is that
Oh yeah, we have many times, yeah. I had an astronomy tent, observatory tent it was called. It's 15 feet by 9 in 2 sections. The left side opens up, the telescope sticks out.
See, thank you for coming.
Okay, good. Hope you enjoyed it. Learned a bit about these crazy rocks, right?